This is the Earth's atmosphere past paper booklet. So the first question shows you two pie charts, one of the early atmosphere, very similar to Mars, and one of today's atmosphere. Use the information in the pie charts to describe how today's atmosphere is different from the early atmosphere. So you just have to pick out certain things on the two pie charts and compare. So today's atmosphere, there's a lot less CO2, there's more nitrogen, 5% compared to 78%, and there's more oxygen, when there wasn't hardly any oxygen in the early atmosphere compared to 21% in today's atmosphere. Use the information in the diagram to describe how volcanoes contributed to the appearance of oxygen in the atmosphere. So volcanoes in the early atmosphere were constantly erupting, mainly giving off carbon dioxide and water. Now, from your biology module, you should know that in photosynthesis, carbon dioxide is taken in by the plants. In the process of converting that to glucose, which is what we need in a plant, they then give out oxygen. So plants photosynthesize, which releases O2 and takes in CO2. The next question then is very similar, asking you to think about today's atmosphere and the three main gases in today's atmosphere. They've even given you loads of different gases. So the main gas in today's atmosphere is nitrogen. Second main gas at 21% is oxygen. And then the other main gas is argon. In 1912, Alfred Wegener suggested that all the continents must have been joined together in one big mass. We call that Pangaea. The diagrams show the position of the Earth's continent at different times during the last 225 million years. Put the letters of the diagram in the correct order on the timeline below. So the first one would have been Pangaea. Then slowly it spread out a little bit to D, a little bit more, then A, and then finally B is what we know it as today. Describe two pieces of evidence that Wegener used to support his theory of continental drift. Similar fossils and the continents all fit together like a jigsaw. You could have written similar rocks, similar plants. The final part of this question talks about how his idea was only accepted in 1960. Which of the following events is likely to occur at plate boundary where they slide past each other? Again, they gave you options and it would have been earthquakes. Question number 4 then, on page number 5, was all about Alfred Wegener's theory of continental drift. You should include, and that kind of bases your answer, and you can see how I've just bullet pointed it, evidence used to support his idea, the reason why scientists did not believe Wegener, and the evidence that now proves Wegener's theory. So they gave you a little bit of a layout there, which would be expected if they didn't even write that and they just wrote that question up there. So continents all moved apart were originally one supercontinent called Pangaea. Wegener had 3 pieces of evidence, similar rock patterns, similar fossils, and that should say, and the fact that they all fit together like a jigsaw. Wegener could not prove how the continents moved apart, which is why no one really believed him. Over time, other scientists discovered convection currents in the mantle, which caused the continents to move. This question then, question number 5, the following diagram shows some of the Earth plate tectonics and the direction in which they move. So different ones, some going towards each other, some moving apart. The boundary between Nazca and South America plates is a destructive plate boundary. Describe what happens at a destructive plate boundary. Plates move towards each other. The more dense plate goes underneath and is destroyed in the mantle, it essentially gets melted. Mountain ranges are formed. Draw a cross, which loads of people will have forgotten to do because it's worth 2 marks. Draw a cross on the diagram to show a constructive plate boundary. Describe what happens at this boundary. Plates move apart, magma rises between them, new land is formed. New land. Okay. So state one other effect of plates sliding past each other, earthquakes. The next question then is quite a long question, all about global warming. So the first part says, draw a trend line on figure 1. So a trend line is where you try and show an increase using a line, showing what's happened with the bars, not taking into account maybe certain anomalies where it's not a complete trend. So your line should have just been going up. Again, make sure you do that because it's worth 1 mark. Suggest where there was a large rise in the amount of carbon dioxide in the atmosphere around 1950, industrial growth. So kind of the start of when we use more cars, factories, which means more release in CO2. Give one way that we are trying to reduce carbon dioxide emissions, renewable energy, mass transport. There's loads of different things you could write there. Some people say that changes in carbon dioxide levels are not responsible for global warming. Tick the statement that supports this. The mean global temperatures remain constant between 1950 and 1980. So there you're saying that in 1950 there was a large increase in carbon dioxide, but the Earth's temperature didn't actually increase that much. So that can't be the reason why it's global warming. So, state how the burning of coal results in the production of sulfur dioxide, why this leads to environmental problems when released in the atmosphere. Include in your answer one example resulting in environmental damage. Burning coal releases CO2 and sulfur. Sulfur dioxide goes up into the clouds and binds with the water to form acidic rain. This can change the pH levels of lakes. You could have put it damaged statues. The following graph shows the amount of coal burnt and the sulfur dioxide emissions in the US between 1970 and 2008. State why the data shows the graph in this graph is not as expected. In 1994, sulfur dioxide emissions decreased as the amount of coal burn increases. Okay, suggest a reason for this. Sulfur dioxide emissions is hard to measure, or that they've started to trap the sulfur dioxide somewhere using sulfur scrubbing. Getting close then to finishing off, there were 2 6-mark questions at the back of your booklet. Fossil fuels such as coal release sulfur dioxide into the atmosphere when burned. This causes acid rain. Describe how acid rain is formed and its effects on the environment. Acid rain forms when water molecules react with sulfur dioxide. This happens in the clouds because sulfur dioxide is a gas and it can rise. This lowers the pH of the rain, making it acidic. All rain is slightly acidic anyway because it isn't completely pH 7. Acid rain has a large effect on aquatic environments such as lakes and streams. This can be harmful to fish and other wildlife. It can also damage statues and it can also cause skin cancer. The main way we stop it is to use renewable energy. So instead of burning coal, that might have been a good thing to add on the end. Using renewable energy, and the other thing you could think about is sulfur scrubbing, which is when we try and remove the sulfur from the atmosphere. So there's 2 extra ways. That might have been a good bit just to add at the end to show your further understanding. This question then was answered very poorly when it actually came up in the exam. Describe how respiration and photosynthesis keep carbon dioxide and oxygen levels constant in the atmosphere approximately constant. Discuss how human activity is threatening this balance. Respiration involves taking in O2, oxygen, in and releasing carbon dioxide. However, photosynthesis is the other way around, in that it releases O2 and takes in carbon dioxide. This keeps the balance constant. Okay, what I would have also added there is the equations for that to kind of show that you've got further understanding. So I'd add in the equations by there. However, as the population grows, this means more people are respiring. There is also more combustion, so more CO2. This means there is no longer a balance and there's a higher level of carbon dioxide. Last question then. Calculate the percentage emission from electricity generation. You basically had to add all them up and take it away from 100, and you should have ended up with 35 as the last little bit there. Explain why scientists are concerned about the release of greenhouse gases, such as carbon dioxide, into the atmosphere. Too much CO2 in the atmosphere means it gets trapped. This causes the sun rays to get trapped, so the earth heats up, global warming. Suggest one way to reduce the amount of greenhouse gases released into the atmosphere due to electrical generation. Use renewable energy instead of using and burning coal.